Hello team, in this video we're going to talk about monolithic applications, which is the classical way of building applications. So one important question that software engineers have struggled with since the beginning of computing is how should a program be structured? And there's no clear answer, so this depends on several trade-offs. Who are your users, what application you are building, where you're going to run this application, and all of these factors go into how we're going to package and structure our app. So a monolithic application is an application with possibly many functions, but in a single program, like just PowerPoint. So there's a single program that I run and it does everything like text, images, it can even record sound and take timings and so on. So a monolithic application has tight coupling between its components. One advantage of monolithic applications is higher performance. So a monolithic application, because it's a single program, it can use shared memory across different modules, and one module can talk with the other by just calling functions. There are also advantages in getting the application deployed. So in a monolithic application, there's one software to install, configure, use, and update. It's like PowerPoint, you just run it and then you have PowerPoint. And if you update your PowerPoint, because it's a single package, you can't have one component upgraded while the other component is not upgraded. And examples of monolithic applications are games. So computer games are usually performance oriented. So they're usually packaged as a single application. An application like Acrobat Reader, Microsoft Word, the desktop version, not the online version. The desktop version of Microsoft Word is a monolithic application in Photoshop. Now, there's a spectrum of coupling in applications. So an application can be tightly coupled or loosely coupled. And monolithic applications tend to be on the left side of this axis. But it's not binary, so an application, even if it's monolithic, can have different degrees of coupling. So an application might be monolithic but have more modules than another one. And examples of this are applications that let you install only some features, or applications that support plugins. And just by looking at the installation procedure, we can see that they have some modularity built in, even if they're monolithic. So we have an example of a monolithic application. So let's look at an application that processes images. So a monolithic application is going to have a main program, like the main that we have in our Java classes or C programs. And this main program is going to take care of running whatever actions the user requires. And it's going to call the different modules of this application as needed. For example, we might have a module to render images, another module to handle different image formats, and brushes and shapes. If you want to modify the figure, you might have transforms like rotate and detect borders, and might have filters, for example, changing the colors, removing red eyes, and so on. So here, the main program can call the different modules to use their functionalities, but one module can also call another module if it needs to. For example, the image format module might be used by the rendering module when reading an image from disk, for example. And this direct use of another module's functionality improves performance. And these modules can also share memory. For example, we can load the image once, and then the same image might be shared across all the different modules while it's being operated on. So can we run a monolithic application in a data center? Yes, we can. We can rent VMs, install the application on the virtual machine, and then we can run the application on the virtual machine. So this is okay. But it's not the best match for cloud computing. If we compare virtual machines with containers, we've seen that containers are more lightweight, so they are preferable, and containers can be started and stopped much faster than a virtual machine. Having a monolithic application running on a virtual machine is not as agile, if you want to use that term, as using an application in containers. And loading a monolithic application in a virtual machine will waste computing resources. So we're going to have to download the whole application, which is going to be bigger than a small container. And because we're going to load the whole application inside the virtual machine, some of the functionalities are not going to be used by all users. For example, a user might be just rotating images, so it's going to be using the transform module, but not the other ones. So those other modules are going to be wasting memory. Another user might be removing red eyes, so it might be running some filters on the images, but not much else.